I decided to make a video going through some of these more difficult structures and kind of showing ones where I can show some different resonance structures with, so this would be an example. There's a couple ones. I had to choose a really hard one because I didn't want to use any of the ones that are on your homework problem. Therefore, I'm using this Thosulfate ion, which isn't on our list of polyatomics, but it is a legitimate one. So it says draw all resonance structures for this ion and then state which is or are best. Okay, so I begin with I need to find out how many electrons I should have. So my total should be, I need 2 times S plus 3 times O. This is the total valence, so I'm looking for my valence. And then I have my charge. So sulfur has a valence of 6 because it's in group 16, and so does oxygen. So this would be 2 times 6, which is 12. This is another 3 times 6, that's 18. And then my charge is, I'm going to add 2 because it's a 2 minus. So this is going to be 20, so this is 32. Also, I need to notice a couple more things just to have it out there, is that when I look at the electronegativity, sulfur is 2.5, oxygen is 3.5. Is 3.5 or 3.0? Let me check. 3.5. So sulfur is the lower electronegativity. All right, now I want to start with my first structure. If you start with your initial structure having only single bonds and having as many as possible lone pairs on the outside of the atom, on the outside of the molecule, then when you go to make resonance structures, it essentially will be moving an outer lone pair to make a double bond or make a triple bond. And you have multiple options for that. If you already have one and you're going to move them around, like I always go back to the initial one, and from the initial one, I say, okay, I could do this, or I could do this, or I could do this. So that's how I'm going to approach this. All right, note that this is a little weird because I have 5 atoms, and so I have 2 of the lowest electronegativity. Instead of 1 central atom, I have 2. So I could initially start off one of 2 ways. I could start off with the S's in line together, S, S, and then putting the oxygens around them. Or I could start off with just 1 central S, and I'll put 3 oxygens around it, and then a sulfur around it. And these are 2 different ways. Normally, I just give you 1 central atom, so this is not normally an issue for you, but this is just the example that I'm choosing. So, all right, that took up 2, 4, 6, 8 electrons, or 2, 4, 6, 8 electrons. So of that, I now have 32 minus 8, 24 electrons left. And I'm going to do them as lone pairs. I'm going to start them on the outside and then move towards the inside. I know I need to get octets. Right now, oxygen currently has 2. It needs 6 more electrons. So I start, and this will be true for all the outer atoms. They all need octets, unless it's hydrogen. So I'm going to put 3 lone pairs on them until I run out. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. I still have more, so I start going to the inner atoms. This one has 2 bonds. It has 4 electrons. It can use 4 more, so I can put 2 more lone pairs on it. 20, 22. I still have 2 left. I can put them here. 24. So let me check. I should have a total of 32 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Great. Same thing over here. Start by putting them on the outside. I have 24 I can put. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I've used them all up. Okay, now I'm going to see, are these, so they have the right total, do they have octets? In general, if you put 3 lone pairs on an outer atom that only has 1 single bond, all of the outer atoms will have octets. I can still check them. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Now the inner atoms I do need to check. 2, 4, 6, 8 for this left sulfur, 2, 4, 6, 8 for this right sulfur, so they're both good. Over here, same thing. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So all the outer atoms have octets, and in the center I have 2, 4, 6, 8. So these are all good. So these are both good structures. I begin with these as my first valid structures. So I have total 32, and I have octets on everything. So these are good structures. From here, I'm going to assess formal charge, and then from that, I'm going to decide how to make resonance structures from it. So for formal charge, and I'm going to do formal charge first because it's going to lead me to say, should I just leave these alone? If these have no formal charges, I'm going to leave them alone. If not, I can start making Lewis structures, resonance structures of more Lewis structures. Okay, so I start looking, remember formal charge is equal to the valence minus the assigned electrons. And in the assigned electrons, each line is only worth 1. So all of these have valence 6. So I'm going to do 6 minus 1, 2, 3, 4, 5, 6, 7. So this is -1. I'll put a negative sign here. This one is 6 minus 1, 2, 3, 4, 5, 6, 7, minus 1. Again, I'm going to put a minus sign here. This one is 1, 2, 3, 4, 5, 6, 7. So this is 6 minus 7 equals -1. Here I have 1, 2, 3, 4, 5, 6. So this is 6 minus 6. There is no formal charge on this sulfur. I don't have to put a charge there. This one is 6 minus 1, 2, 3, 4, 5. So this is a +1. I'll put a plus sign here. So I have formal charges in this. I'm going to try and figure out how to get rid of them. With this, I expect no matter what, I will have at least either 1 quantity 2 minus formal charge or 2 1 minus formal charges. I can't get rid of that. It's got to show, it's going to have a -2 charge. But I don't need 4 of them, and I don't need a positive and a negative, right? If this one went up 1 and this one went down 1, then I'd only have a total of 2. So that's going to guide us into where we want to go with resonance structures. For this one over here, I have 6 minus 1, 2, 3, 4, 5, 6, 7, -1. 6 minus 7, -1. This one is 1, 2, 3, 4, 5, 6, 7. 6 minus 7, -1. And 6 minus 7, -1. And in the center, I have, for here, 6 minus 1, 2, 3, 4. That's a +2. All right, so +2, negative. This one's even worse, right? Here I had just 4 total. Here I have 1, 2, 3, 4, 5 total. And one's a +2. So it's like I got to get rid of this +1 and at least 2 of these negative ones. That's where I'm kind of aiming for. So with that in mind, also I need to remember, can I make double bonds when these already have octets? Sulfur is period 3. So it can have exceed 8. It's one of the periods 3 through 7 can have more than 8. And I do that. I will have an extended octet where I add more than 8 electrons around it if it does something to reduce formal charge. Okay, so notice I have a couple of options. I could work on getting rid of this one. I could work on getting rid of this one. So I could take one of these and make a double bond, or I could take this and make a double bond. Let's see what happens when I do each one. So O, note that I didn't cover that one, and I put the S here. I leave everything else, I'm just recopying. And again, I'm thinking, like usually when you make this double bond, you change both of the atoms that you made the double bond formal charge from. So I'm thinking I'm just going to need to do one of them on this. So when I do this and I check, none of this changed. So I know that this is still going to be minus over here. But and I didn't change this one, so this is now minus. The two that I changed were these two, so let's reassess formal charge. This one is 6 minus 1, 2, 3, 4, 5, 6. So that's 0 now. And this is now 6 minus 1, 2, 3, 4, 5, 6. Okay, so notice, now I've gotten to a structure. By making this double bond here, I got to a structure where I have reduced the formal charges down to the minimum that I'm going to get, because this has to have a -2 charge no matter what. And the minimum way I can get that is either 2 -1 charges or 1 2- charges. This one's better because it's fewer of them. This one's better because they're smaller, so they're equivalent. Either one of these would be okay. So but I could have done it here. However, I could have also done it here. So let's do that other Lewis structure. And in this case, I would leave the left one alone. I'm only going to change this bottom one. So I'm going to reduplicate everything that I had in the original structure. This one had a negative charge, and I'm leaving everything on top. This one had a negative charge, but I'm going to change this one. I'm going to get rid of this lone pair, and I'm going to make a double bond instead. When I do, this is 6 minus 1, 2, 3, 4, 5, 6. And this one is 6 minus 1, 2, 3, 4, 5, 6. So again, both of these would be considered good Lewis structures, better than this one. Let's do the same thing over here. I don't really know that I could do anything. If I try to do this one, it's going to be challenging because when I could do it, but it will reduce this charge, but then it's going to put it on here as well. So, but I mean, just for fun, I could show you that I could do that. Another option is I could take one of these and put it there. Okay, so that one would be O, S. All right, so these all stay the same. This one was minus. So here, oops, those are the ones I was going to get rid of. So I take this pair and I make a double bond here. So notice that this now is 6 minus 1, 2, 3, 4, 5, 6, 7. So that's a -1. And this is now 6 minus 6 is 0. So now I don't know that I got any better. Let's put that in purple to be consistent. So I still have 3 negative charges, and this one still has a positive charge because I didn't touch any of those. So I didn't really make anything better by doing that. So the ones that made it better were where I came up with these structures. Okay, so now let's go and do the same thing over on the other side. So I'm going to start with this structure. Again, I'm looking at it and I'm saying I could make one double bond, or I could make a couple double bonds. In fact, I think I'm going to redraw this on the next page just so I have a little more space. So we had, I think I had this sulfur on this side. And this was negative. All of the outer ones were negative. And the inner one was 2+. So I have several options. So for one, I can just take any one of these one pair and make a double bond. And I could do that on any outer atom. So I could do this one, top one, Now again, didn't change any of these outer ones. So the only two that changed is this one. This one is now 6 minus 1, 2, 3, 4, 5, 6. And the center is 6 minus 1, 2, 3, 4, 5. So this would be positive. Okay, so that got a little better. But I also could have done it by either making the double bond with this oxygen or with this sulfur. So I will show you all of those. I can make a double bond with the sulfur, leave all the oxygens with 3 lone pair. And here I had 2 pair because I used 1 to make the double bond. And when I'm done, you can check it. This one's going to be positive. This one's going to be 0. These are going to be negative. I could have made the double bond on the right. Now the left and the bottom and the top didn't change. But this one I used up one of the lone pairs to make a double bond. Note that now I have 1, 2, 3, 4, 5, 6 around this oxygen. 6 minus 6 is 0. And on the sulfur I have 1, 2, 3, 4, 5. So 6 minus 5 is a positive. So, and then I had the bottom one I could have done. So I'm doing 2 things here. One, for the problems where you're asked to show all the resonance structures you're seeing, what's changing is where I'm making the double bond. So this was negative, this one was negative, this one was negative, this one is going to give me 0. 6 minus 1, 2, 3, 4, 5, 6, that's 0, and this is going to be positive. 6 minus 1, 2, 3, 4, 5. So now, in these cases, they're really all the same, except I have a positive in the center, and I have 3 negative ones on the ones that don't have a double bond. The one that does have the outer atom that does have the double bond has become 0 formal charge because these are sulfur and oxygen. Again, it depends on what the outer, you can't just say, oh, if it has a double bond, it's a 0 formal charge. It depends on what the valence of that atom is. That is true if it's oxygen or sulfur, because they both have valence of 6. And a double bond with 2 lone pairs is an assigned electron of 6. All right. These are still not the best as I had on the other page. I could go and make another double bond from these. And that maybe I can get, I improved a little bit. I can probably get it down to where I have at least 2 individual negative charges, but I can get rid of the 2 of the formal charges. So I'm going to try and go to red. Okay, so now I'm going to take any one of these that still has a negative and make another double bond. So I could end up with a bunch of structures. I can have a double bond with the top and a double bond with the right. I could have a double bond on the left and a double bond on the top. I could have a double bond on the left, or it should and a double bond on the right. I could have, let's see, I've done 1, 2, 1, 2, 1, 2. I could do double bond on the left and a double bond in the bottom. Oops, this should be oxygen. I have lots of varieties. I haven't exhausted them all. So the ones that don't have double bonds had 3 lone pairs. So anytime it's a single bond, it had 3 lone pairs. I didn't move those. But the way I made the double bond is I used one of the original 3 lone pairs. So anytime it's got a double bond, I made it from one of the lone pairs, so you just have 2 lone pairs. And I could have done this more slowly and gone through every option. I'm trying to get the idea, where you see like what things you can play with and what things you can't. 2 there, 2 there, okay. 2 there, 2 there, 3, 3. So in any one of these, I will just do a formal charge assessment. All right, so they're all have valence of 6. So 6 minus 1, 2, 3, 4, 5, 6. This is going to be 0. 6 minus 1, 2, 3, 4, 5, 6. That one's 0. 6 minus 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. This one's a negative. This one is 1, 2, 3, 4, 5, 6, 7. That one's negative. This one is 6 minus 1, 2, 3, 4, 5, 6. So this is 0. So note that I got to a structure with only the ones that don't have double bonds have a negative charge. So this one would be negative. That one would be a negative. This one's a negative. This one's a negative. And I probably had a couple more varieties of which two atoms, right? Because I did the top and the right, and I did the top and the left. I didn't do top and bottom. I did the left and the right. I did the left and the bottom. I probably got a couple more options of where I could put the two double bonds, but they're all going to end up about this, like this. Now, the last part of the question asked which are best. So I'm going to kind of number them. I'm going to go back to the first one that we had. Let's go to black. All right, so this was number 1. This is number 2. This is number 3. This is number 4. This one's number 5. This one's still the same number 5. I just recopied it. This is 6, 7, 8, 9, 10, 11, 12. This one's 13. I probably have a couple more I could have done. When I'm looking for my best, it's going to be examples where I have, I'm looking for the fewest formal charges. So I'm going to look for ones where I have 2 -1 formal charges. And I want them on the more electronegative atom. And remember on that last page we'd gone back and we said sulfur is less, has a 2.5, oxygen has a 3.5. So I want them on the oxygen. So any of the ones where I have 2 oxygens, both with negative formal charges, will be the good ones, and no more, only 2. So in other words, this one, it's on a sulfur, not oxygen, so that's not. This one, it's on 2 oxygens, so 11 would be a good example. This one has 1 to the sulfur. This one has 1 to the sulfur. These have 4 charges. That has 5 charges when I go up to this page. So 2 is good and 4 is good. Well, 2 is good. Yeah, 2 and 4 are both on oxygens. They're good. So 11, 2, and 4. And I think there actually would be a couple more where I had them. So in other words, right now I have 11 and has it on the right and the bottom ones. I could also have one where there'd be 2 more. There'd be one where the single bond is with the top and the right one, and one where it's the top and the bottom one. Oh, this one, 12 is that one, right? Look, 12 has oxygen and oxygen. So 11 and 12. So I think there would have been one more where I had the double. Oh no, 13 is good, right? So 13, they're both on oxygens. 12, they're both on oxygens. I may have them all. And so these would all be ones that are equally the best. I hope that kind of shows you how you start with one and then come up with the different kinds of resonance I could have. I came up with 13 resonance structures here on this one. It's a pretty complicated one. And then also about how to figure out the best one. Sometimes from that initial one, when I'm looking at like this initial one, I'm immediately saying, okay, I need to have 2 -1 charges. And right now I can get rid of the +2 and 2 of the -2s. And wherever I want to get rid of it, that's those atoms, the atoms that I want to change the formal charge, that's where I'm going to try and make it a double bond. And that will help us take care of those. I hope that's helpful.